technology actually calculate this for us momentarily. This is the first and only time you'll ever do these by hand. Because it's silly. I mean, imagine if you had 50 data points. Actually, don't imagine, that's awful, right? Let the machines do it for you. Here's the deal. 1.58 points, yeah? What does that mean, 1.58 points? Vivica, go! Be brave!
That's the deviation from the mean.
I love that. Can you put 2 more words in there? Or maybe 1 more, depends on where you put it. Maybe a comma and 2 words, or a comma and 1 word, or something like that. So you hear what Vivica said? She said it's the deviation from the mean. It's the average deviation from the mean. You see what I'm talking about? On average. This is why I didn't know if we could hit 1 word or 2 words. Veronica used 1. On average, comma, the data points in Ernie's data set are about 1.58 points away from average. Is any one of them exactly 1.58 points from away from average? No. No, but remember we talked about averages. Averages don't have to actually contain one of the data points. We had 4.3 keys or something like that last week. Yeah, 4.3, we don't have 4.3 keys. But we averaged 4.3 keys. So what this number means is, on average, the data points in the data set are 1.58 points away from the 81, which is the average of the data set. Alan, have we measured your disparity? I think we have. We've also given it a number, which is great, but the number ties back to the actual average. That's what makes me the happiest. Pat, ask me that question. Or are you still trying to formulate one?
So 1.58 would be the average standard? Say that again?
Yeah, on average. It is, first of all, it is what's called the sample standard deviation, otherwise known as S. So whenever you have an X bar, you should have an S that goes with it. The S should also occur with the X bar. Now, you don't often see this in the news, unfortunately, but it should be there. So the idea is, this number needs to be paired with the average to give a more complete picture of this variance. What the 1.58 points means is, on average, let's put the graphic back up. I'm going to swing that. Nick, you just pay attention to this. I'll get the camera for a second.
Oh, no, I got it.
You sure?
Yeah.
Excellent. Can you see the entire number line here with Ernie in it?
Yeah.
Okay, good. What it means is, if you take the distances of all those test scores from the 81, on average, they're 1.58 points away. Some are 2, some are 0, some are 1, but they average to 1.58. Now, Ariel's like, okay, I'm starting to buy this. I'm buying this now. Good for you, sister. Good for you. Now, Veronica's measure actually is a more perfect measure of that average by taking the absolute values and averaging those, but nobody uses that. But that doesn't mean you can't view this one as almost exactly the same, because it is almost exactly the same. It is almost exactly the same. So the idea is, I think if you did it Veronica's, it would be 1.2, I believe. Because you have 1 plus 2 plus 2 plus 1, which is 6 divided by 5 is 1.2, which is close to 1.58. So think of it like that. If you were to add up all these distances, Pat, that distance, that distance, that distance of 0, that distance of 1, that distance of 2, if you were to add all those together and divide, it would average out to about 1.58. That's the way you want to think of the standard deviation. It's an average. It's an average disparity from the average. You have to use the word average twice when you're interpreting to somebody. Because you're talking about disparity from the mean, so there's your first use of the word average. And then you have to quantify it with, on average, it's how far apart they are. So Carly, coming back to your awesome idea earlier, this uses all the data points, not just the highest and the lowest, not just the extremes. You see the difference? Before you said, let's look at the -2 and the 2 and talk about that range versus Bert's -20 to 19, I think it was.
Yes.
But this uses all 5, not just the most extreme values. So it gives you an idea of the entire data set. Fair? Now, you guys have worked. I apologize. What we're going to see now is how to get that number without going through that awfulness that we just had to go through. Because it is kind of a pain in the butt. And I don't want you memorizing or anything like that anyway. And nobody actually calculates it manually anymore anyway. The important thing, as Ariel just pointed out, the important thing is knowing what the number means. That's the important thing. We'll come back to that over and over again. Grab your machines if you have them.
Can you say that on average thing again?
Sure. Actually, somebody else say it. Interpret the 1.58 points for me using the word average. Cassidy, go for it, please.
So 1.58 is the deviation from the,
No, you're almost there. Say, finish.
is from the total average.
Good. If I put one word in there, we've got it perfect. What she said was, it's the deviation from the average of 81. I'm just going to put one more word in there, and that word is? It's the average deviation from the average of 81. Basically. And the implication is you're measuring all the data points, not just the extremes. That's perfect, Yasmin. Thank you. And it's not an inherently intuitive thing, because you've never heard it before, most likely. You know what an average is. You know what an average is when you walked in here on the first day of class. I doubt very much anybody knew what a standard deviation was when they walked in here on the first day of class. We're learning it right now, and that's that first, like, okay, this is new, doesn't feel fun anymore. It will become much more sensible as we go through this class together and pair it up. Because Americans suck at understanding this. Okay, cool, you guys know it anymore.
So
Go, Ariel!
if we did BERT's standard deviation, it would be a much larger number.
Do you hear this? If we did Bert's sample standard deviation, it would be a larger, I don't know how much is, but yes, it would be larger. It has to be, right? Because if you think about it, his distances are larger on average. His deviations, his disparities from average are larger on average.
So that would tell you a lot about the data set that you were given if you
It
don't know
would. It doesn't, oh, I've erased the range now. I apologize for the range, Jolene, your range earlier. It would tell you more about the data set, because not only do you have your average there, but you have the spread around the average there. Yes. Let's do Bert's and Ernie's in the machine so you can see exactly. I don't want you to get caught up in this. This is what I don't want you to get bogged down in, because it's so easy mathematically to get bogged down in a formula like that and be like, oh God, I got lost halfway. Let the machine, that's why we invented these things, to do the nasty math so we can interpret the results. That's the reason we have computers, believe it or not. Believe it or not. I'm gonna go over there, I think. And yeah.
Can we do earnings?
What's that?
Can we do earnings? Well,
Yes, we're doing Ernie's and Bert's at the same time. Well, not at the same time, sequentially.
Okay.
Yeah. Let's clear this out. Can you guys see this yellow rectangle in that screen on the board? Is that pretty good? Ish?
Yeah.
Okay. So here's what I want you guys to do. Put Ernie's data. Now, actually, let's do a tutorial here. We're going to be entering data a lot in this class. So if you've never done this before, here's a good tutorial. Nick, would you mind stopping and starting?
Sure.
Oh,